Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
I'm Haaris. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media.
All right, Haaris, nicely done. Thank you for taking care of that for us, because I know Scott and we stumble over that every once in a while, so nicely done. So Haaris, where do you go to school?
I go to school at Reagan Elementary.
And what grade are you in?
I'm in 4th grade.
How is 4th grade so far this year?
4th grade's pretty fun.
Good, I'm glad you like it. So you guys, I think this is conference week for you guys, right? Where you get your report cards, and your first report card, I'm sure, is pretty good? Mm-hmm. All right, good. So how is math class in 4th grade?
It's okay.
What kinds of things are you doing in 4th grade math?
We're doing division and multiplication right now.
And is it division like 28 divided by 4, or something a little more difficult than that?
Like 28 divided by 4, and sometimes a little harder than that.
So can you give me an example of one that would be a little more difficult?
Like 35 divided by 2.
So are you doing things where you have remainders possibly?
Yeah.
Oh,
Sometimes.
good. All right. So maybe you and Scott can work on a little bit of those later on today. So do you like going to school for a little bit longer time now this year? Mm-hmm. Oh, good. All right. Well, you know, it seems funny because a lot of kids don't have a problem going to school longer, even though it's not as long as it used to be, I think.
Right.
Because it used to be when you got into 4th, 5th, and 6th grade, you go for 30 minutes longer. Now it's only 10 minutes because they revised all the times on things. So making up pretty good there. You ready to help me out with the social media problem of the day? Mm-hmm. All right, let's take a look at it together up on the screen. So this gets sent out, and then people answer it on our social media, and then they tune in later on, like right now, and see how they did. So it says, if Mike builds a rectangular patio that is 9 units wide and has a perimeter of 40 units, what is the area? So Haaris, when you look at that, what is something that you notice? What do you, what gets your attention when you look at that?
The units and the perimeter.
Okay, so perimeter. Do you know what perimeter means?
Yeah, the outside of the area.
Right, so it's the outside, if we wanted to go around the outside of something, right? And the area is all of the space inside of it. Good. So what numbers do you think we need to pay attention to up there?
9 and 40.
Good. And the units just means it can be anything, but we're just going to call it units, because it could be millimeters, inches, feet, miles. It could be anything. So it says the patio is 9 units wide, but the perimeter is 40, and it wants to know the area. So how do you think we're going to figure this out?
We could do 9 times 40, I think.
You could, right? That would be a pretty big number, 360, right? As far as now, if it's 9 units on the left-hand side as we're looking at it, what would the units be on the right-hand side?
9 units.
So together that would make
18.
18 units, right? And we know the whole thing going all the way around is 40. So if we have 9 and 9 is 18, can you think in your head what we would have left? If the whole thing is 40 and we have 18 already.
I would think like 20, somewhere in the 20s, like
Right,
22.
exactly, somewhere in the 20s, right? It would be 22, right? Because then 22 and 18 would make 40. Now, if the top and bottom are both going to need to equal up to 22, what do you think either one of those is going to be, either the top or the bottom?
The same thing, larger than the sides.
Okay, so if the top and the bottom make up 22.
Oh, I think the top would be like 11.
Yeah, and how did you get 11?
I got 11 because I know 22 divided by 2 is 11.
Perfect, all right. So we know the left and the right is 9 units. The top and the bottom are 11 units, because then that gives us our 40 units for the perimeter. So if the measurements are 9 by 11, how do we figure out area with those numbers?
We could do 9 times 11,
We
which
could.
was 99.
Good, and so we see 99 up there, and that's D. But why does it say units with the number 2 up there? Do you know what that little number 2 means?
Squared?
Squared. And what does that represent? Or what does it mean? Can you tell me what that means or what? So if you're multiplying 2 numbers, length times width, all right? So when you're doing multiplying, you're gonna get the area, that is the area squared, right? So the number is squared because you're taking the square area of that object. Does that make sense a little bit?
Yeah.
All right. So we know that the units are 9 and 11, so you think 99 is the correct answer, D?
Yeah.
All right, let's take a look and see if indeed you are correct. There you go, 99 units squared, dude. Nicely done. First problem out of the way. Feel pretty good?
Yeah.
All right, there you go. 636-4357 is the phone number. We do have phone tutors available today and most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, well, today, Math in the News, we are fortunate enough to have some guests in the studio. Carter, a repeat guest, how are you today?
I'm well, how are you?
I'm excellent, thank you. Nice to see you brought along a partner of yours in Virtual Enterprise today.
Yes.
Navnoor, how are you today?
I'm good. How are you?
I'm excellent. So, what year in school are you?
We are both seniors in high school.
So you're both seniors, and you're both at the same school,
Yes.
because that otherwise would be kind of difficult to do your Virtual Enterprise together. And where is it that you attend school?
Centennial High School.
Centennial High School, and you are a Hawk then? Mm-hmm. All right. So do you have plans for next year? Because I know your senior year, you probably already had plans when this year started as far as after school. So what are your plans for next year?
Yeah, so business law. I'm planning to have a career in law school, so that's my plan.
So business law?
Yes.
So the Virtual Enterprise is a nice stepping stone for you to get used to that.
Good experience.
All
for
right.
sure.
And Carter, you were here because of the the book vending
Yes, I
machines that
was.
you had, right? And once again, remind everybody your plans when you're all through with school.
When I'm through with school, my goal is that I would like to get a degree in public policy, and I'd like to start my own nonprofit organization and eventually run for elected office.
Oh, there you go. Well, you know what? I'm glad that when you guys are through with school, you're going back to school, because that's one of
Yes.
the best things you can do. Just keep that education going right there.
For sure.
So today we're here to talk about your virtual enterprise and what is going on with that. So, Carter, how did this all start? Like, who developed this plan? What did you guys do to get started with all of this?
Yeah, so Virtual Business is an international program that happens at high schools all across the world, and Centennial just happens to be one of the schools that participates in it. Every year we make a mock business, and it goes into like this network of all the schools across the globe, and we all compete on different things, from our business plan to even our marketing strategies, and it goes all the way down to even our newsletter and our interview capabilities. Yeah. So.
Okay, so is it just one plan, one business per school, or are there other businesses at Centennial?
So it depends on the school. Centennial, we take a lot of pride in our VE program, so we actually have 2 businesses that are running. We have a junior class and we also have a senior class.
Okay, because I was going to say, I know some of the high schools, the other high schools do it also, but it seems like Centennial's always listed and one that you read about and things like that.
It's a nationally rating school, so we have big shoes to fill this year, but it's a great program for experience in the business world. You learn skills that you wouldn't normally learn in a traditional classroom.
So when did you, Navnoor, become interested in this? Because obviously you want to step into business law, but there must have been something that struck a nerve, let's say, earlier that made you want to get into this in the first place?
Yeah, so my family is involved with business. I was kind of born into that atmosphere, so my whole family, they own businesses.
Okay.
And then sophomore year, I heard about virtual enterprise, and that kind of sparked my interest in that. So I applied, and then I joined the junior class. So in the junior class, I was able to learn all the curriculum I needed for the senior class. And then in the senior class, I was able to earn the chief executive officer position.
Oh, so you're running the show now, huh? There you
Yeah,
go.
so
Big boss.
yeah, it's a great program. program. I've learned so much, and I'm still learning as we go. But yeah, it's a great program for sure.
All right. Well, I understand that you've got a program that you're going to kind of guide us through. So let's go ahead and take a look at what you've got.
Yeah. Alrighty, so Mirova is our company for this year, and essentially it's a fashion subscription box, and inside the subscription box is a stylist curated outfit based on your body type, skin tone, and hair color. So each outfit is really individual to each client, and we aim to boost confidence and boost body positivity because we notice a lot of teenagers and young adults struggle with body image issues.
Okay.
So that was our mission this year with Mirova. So I'll kind of walk you through what Mirova is. Again, we want to empower teenagers and young adults to be more positive about their body because a lot of people do struggle with body image issues, and it's an upcoming issue. It's upcoming and it's been around for as long as we can imagine. So that's something that we wanted to focus on this year, and we do that through a curated fashion experience. So we try to make it more lively and more fun. But yeah.
So what is Mirova? Again, Navnor kind of touched on it a little bit, but we are a virtual business company and we provide monthly subscriptions. So the idea is that we want to kind of remove the chore of shopping and make sure that we can curate outfits that are designed for the person and it goes straight to their door.
So instead of going out to a
Yeah.
store, they're doing it online, which a lot of people are doing anyway.
Mm-hmm.
And is it kind of aimed at a certain demographic?
Yes, so we are targeting teenagers specifically, and
Okay.
our kind of thought process behind this is that, you know, with the upheaval of like social media and just like societal stigma, we see that confidence for teenagers is at an all-time low. And clothing can play a really big factor in that, whether it's having the best new fashion or keeping up with the trends or anything like that. There's a lot of things that go into kind of curating what fits you fashion-wise.
And if they know something is designed for them, they'll feel better about themselves also, right? More
Exactly.
confidence, and this is what you want to bring out in the kids. All right.
Exactly. Yeah, so this is our team. We have a team of 22 employees, and each person has their own role. So I'm the Chief Executive Officer. Carter is our Director of PR. So he is making connections all throughout. He's already such a known person in Bakersfield, so that's one of the reasons I chose him for the position. But yeah, so he's been doing great. But this is our team, a team of 22 students.
So this is one of our boxes that we had to offer. We recently had an open house event, which was really exciting. A couple of different schools in Bakersfield we know do open houses, but this is not something that's required by VE. We decided to do it because it's a way to kind of gather our community together and as well as our school and kind of show them a little bit more about what VE is about. So as an example, this is a 4-month subscription that comes with an accessory pack. So I know that for the spirit of do the math, we can talk a little bit about the math. The $459, including in this 4-month subscription, on a typical subscription would be about $99 a month. And then we estimate that this box is approximately $70. So you're really making your money on it if you buy this box.
So who is setting the price at $459?
We have our class is split up into different sections. So we have an operations, we have marketing, and we also have finance. So our operations and finance teams kind of work together to make sure that these prices accurately reflect real life wholesalers and things like that. So they kind of came together to curate the perfect price.
Well, I was going to say, because I know you guys are seniors in high school and you're well aware of prices in
Oh, yeah.
the real world. But as you get older, you're also going to notice that there's always a 9 at the end of everything,
Exactly.
right? And there's
Yeah.
reasons for that. Now, you were talking about all the employees, 22 people at your business. So as a virtual enterprise, you have to pay all of these
Yeah.
people. So
payroll,
the
we do
money
have
that
to.
you are bringing in
Yes.
is from this
Yeah.
and anything else? And then how do you account for how much money people are getting paid?
Yes.
And is it different based on position?
Yeah, so it does vary based on positions, and our chief financial officer, so she goes through this whole process, and we do have to pay payroll every month, and in order to do so, we do have to sell these boxes, which is another reason that we do have the open house, is to get the company really started, and our projected sales price was $200,000 for the open house. That's what we wanted to hit to break even, and we ended up exceeding our sales projections, which was super exciting. We hit $245,000 $5,000.
Money to
And
bank.
that money that's coming in is how we are able to pay our employees that we have. So yeah, it is a simulation of how business would work in the real world, which is why it's such a great program. And one of the reasons Centennial is nationally recognized is because the way that we go about executing our companies is how you would realistically in the real world, and that's what teaches you how to run a business. But yeah, so that's kind of the finance aspect. We did exceed sales projections, which was super exciting. Our team worked so hard. We had over 500 students come to open house from, it was 8 to 3:30, and 500 students came and showed support, which is super nice, yeah. So it was a good experience for sure.
Nicely done. So tell us a little bit more about the Starlight box.
Yeah, so in the Starlight box, we have 2 curated outfits plus an accessorizable item. So in all in our boxes, there's 3 items. And whether that be 3 clothing items, 2 clothing items with 1 accessorizable item, so that could be a hat, that could be sunglasses, that could be a jacket over a dress. We aim to hit 3 curated items, so you are getting your money's worth with that $99 price point. And you had mentioned why we prices typically have that $99.99. We do have a rounded pricing, so where it seems more appealing to the eye.
Right.
So for example, if someone were to see $99.99 on something, they'd kind of be drifted away from that price versus just $99 flat. And with the $4.59 that we had, it just appeals more to the eye, which is why we don't use that specific pricing strategy, but we use another one instead.
There is a number bias in everything is price. So.
Yes, so that is what is in the Starlight box. Then we can move on.
So these are a list of our corporate sponsors. A big part of the math that goes into virtual business is the real math behind it. And so this is actually something that, as the Director of Public Relations, I deal with. So throughout the year, we have so many different ongoing events, including our open house. And throughout the year, typically our team makes it to a bunch of our competitions, including one in New York. And that costs real money.
I was going to say, because I know you guys go to New York and I've
Yeah.
seen that many times, and that's big.
That's generally one of our big appeals to getting people in the class. I kept
Yes,
telling
right.
them, I said, if I can't sell you on our product, I hope I can sell you on the New York trip. But
That shouldn't take much doing right there, but anyway.
But we do have to fundraise a lot of money, and so that's part of my job. And these are some of our great corporate sponsors that generously supported us throughout this beginning of the year. And together, through all of them, we were able to raise about $4,200. So we're very grateful for them.
Glad that you guys were able to recognize those sponsors as well here on Do the Math.
Yeah, no.
So nicely done. So come on back over here for a quick minute. That was the end of your presentation,
Yes,
right?
that
Just
is.
want to make sure you hit this corporate sponsor right there. So when is your competition coming up? So I know
Yes.
that you've got, because this is, like you're in it, but
Yeah.
what's
yeah,
the next
so
step?
we started preparing in the summer. That's when we had our business idea where everyone was pitching in their ideas that they had. But the competition is coming up December 9th. That is our state competition. So that's going to be super exciting. They're coming up a couple more months and we're going to start competing, but they are coming up.
I was going to say, because
Yeah.
that's when you start making the moves, win the
Yeah.
state, move on, and then
Yes.
start dominating then
Yes.
after that, right?
Yeah, so that's the goal. Our goal this year is to make it to nationals and place high and continue Centennial's legacy.
Well, that is the goal, is to place in nationals. The goal is to win nationals, right?
Yes.
It's like, all right, we got there, that's all nice,
Yeah,
right?
so step by step, we're taking it step by step, but our team is working hard every single day, and I'm so proud of all the effort that they've been putting in. So I'm excited to see how far we do end up, and I have faith in our team.
Yeah.
Well, here's what you guys are going to do. You guys are going to do well, and what you're going to do is you're going to come back and let us know how you did, all right? Because I have every confidence you guys are going to be able to move on to nationals and do well. You come back on Do the Math, you go, hey, old man, we're back here again, and guess what? This is what we got. This is how much more money we got. So anyway, Carter, Nodnor, thank you very much for coming in this afternoon.
Thank you for having me.
Continued success to your program, and hope Mirova makes a ton of money.
Thank you.
All right,
All
thank
right.
you so much.
Hey, you know what? We'll be back with more right after this.
Hi, I'm Dereck, and this is Pascal's triangle. Pascal's triangle is a triangle or a pyramid that uses a pyramid of numbers and has very many patterns. To start, let's number the rows. We have 1, 2, 3, 4, and 5. When I count this one. Now, Pascal's triangle adds numbers. So we'll start with 3 ones at the top and then ones down. 1 plus 1 is 2. 2 plus 1 is 3. 2 plus 1 is, of course, 3. And then it keeps going down. For example, 3 plus 1 is 4, and 6 plus 4 is 10. Now, going to the rows, we have 1, 2, 3, 4. And with the third row, I'll show you the first pattern. Getting all of the numbers and then putting it up into one number from the third row is 1,331. Now, this pattern uses 11 and it's squared. So this is the third row. So with 1,331, we can actually get this number by multiplying 11 to the power of a number. Now, getting rid of this 11, this is the third row, so we're going to multiply 11 to the power of 3. Now, 11 to the power of 3 is going to be, of course, 11 times 11 is 121, and then 11 times 121, with some quick math here, is going to equal 1,331. Now this works with all rows. For example, this one right here, we'll do that one too. 1, 4, 6, 4, 1. Now, since it's the fourth row, we can get 11 to the power of 4. So we already know that 11 to the power of 3 is 1,331. So we can just multiply that by 11 one more time. And this is going to equal 14641. Those are some patterns of Pascal's triangle. Thank you.
And a big thanks to Dereck right there. A lot of patterns you can find in Pascal's triangle, and that was just a little bit of work with Pascal's triangle. In studio, we have Haaris, a fourth grade student from Reagan Elementary, and is working on a bit of division in his regular ed classroom. So Haaris, take it away. You and Scott are going to do a little division right now, and we're going to kind of expand and push you a little bit, but let's start with a quick and easy one.
All right, there you go. When you see division problems, a lot of times you'll see them, they look like this, right? Let's say we have 36 divided by 3, right? Do you ever change the way that looks before you start a problem?
Not.
No? So how would you go about doing this problem?
I know the basic math fact, 12 times 3 equals 36, so I would know it's 12.
Wonderful. So you can go ahead and put an equal sign here and you make your answer. So if you happen to know how many times 3 goes into 36, right off the top of your head, wonderful, you can just have an answer, right? What if we have something a little bit bigger? What if we have something like 75 divided by 5? And maybe that's not right in your head. How would you go about solving this problem if you didn't know the answer right away?
I would draw circles and then make...
Oh, show me. Circles. All right, I want to see this.
I would draw 5 circles since
Okay.
I'm dividing by 5. And then 75. These ones stand for tens, so I'll draw 7 ones.
Okay. There's 5 of them there. 6, 7 ones. All right, that's for the 7, right? Okay.
And then the ones.
Okay, I'm going to change colors on you so you can go with the ones with something else.
The ones would, there's 5 ones, so I'll draw 5 dots.
Oh, gotcha. Okay, so the 7 is the ones that you have there, and the 5 is the dots. All right.
Yeah.
What are you going to do with that then?
I would put them equally into these groups. So
All right. See what you got. Go ahead.
Do 1 in each group.
Oh, I gotcha. So you're moving the dots around.
And then
Good. This
I
is a
would
wonderful visual representation of what you're doing there. I like it. Good. Let's go back to black so you can move those big ones, right?
So
Go ahead.
I would put 5, 1 in each circle.
Good. This is a great way to do it. You
And
can
then
see
cross
exactly what's
them off.
happened. 1, 2, 3, 4, 5. Okay, so now what we have left is these 2 ones, right? But you got 5 circles. What are you going to do now?
I would make these into ones.
Uh-oh, we better change back to red then. Let's see what you got.
So each one stands for 10, so that would be 20. So I'll
I
draw
like it.
20
Okay.
dots.
And so you're making 10, 20 dots, right? I like it. Wonderful.
And then I would put 1 dot into each of the circle.
Okay.
So
1, 2, 3, 4, 5. I'm going to help you. Ready? 1, 2, 3, 4, 5. All right, what else you got? Do it again. 1, 2, 3, 4, 5. All right, good deal. 1, 2, 3, 4, 5. All right, what else we got? Keep going. 1, 2, 3, 4, 5. Good. 1, 2, 3, 4, 5. Oh, wait, sorry, it's right there. So you got these ones left right there on the bottom.
So so it would equal. So I have.
We're not even going to have any left over, huh? You can put them all in there evenly. Go ahead and put those ones in there.
1, 2, 3, 4. I can't put.
We got 5. Yeah, there's one left
5.
there. I accidentally crossed it off. I'm sorry. Look at that. That worked out pretty well. So, with your picture that you've drawn, not only does it look like pizza, which everybody likes, what's the actual answer to this problem?
So the ones would stand for 10, and then since there are 5 ones in each circle, it would be 15.
That's it. You got it. So go ahead and put an equal sign to 15. And what a wonderful visual representation of what's going on there. You have a picture that goes along with it. You got something physical to do. And I know a lot of younger students really like to have something physical to be able to do the problem and not just all the numbers. You can actually see what's going on here. What if you happen to have, kind of like you were saying, I'm not sure if we have enough. What if you happen to have like one more? What if we had like, if this was like a 76 and we had one more dot? What would you do with that, and what would the answer look like at the end?
I would put R for remainder, and
Okay.
I have 1 extra dot, so that means 1. So
That's it.
Put a dot, 15 remainder.
Right, so it's almost like you have one extra little pepperoni here in your pizza, right? You could put a P for pepperoni, but I guess R is better for remainder. Gotcha. So if you have some left over, right, then you have to have a way to show that, and that's what the R is with one more. Now, if you had a really big number, it would take you quite a while to draw a picture, right? Do you know any other way to divide it all that works out real well for you to be able to do something like this, come up with a numerical answer, but not have to draw a picture? Because I love your pictures, but let's say we had, oh my goodness, what about 1,345 divided by 5?
And
Oh my
that's
gosh.
something that I think you guys are going to work on next, because I think that circle right there was an excellent idea, especially
Yes.
for some students that aren't quite familiar and confident with division yet. So that was some really nice work right there, and being able to explain how you're representing the ones as representing tens and things like that.
Yep.
For some great work so far this afternoon. You've got yourself a pass to any athletic event at CSUB, so congratulations on that. Hopefully you have an opportunity to go out and see one of your favorite sports, or maybe find out about a new favorite sport. We'll be back with more right after this. All right, in studio with us now we have Amy Moser. How are you today?
I'm great. How are you?
Excellent, thank you. So you are an employee of KCSOS.
I am.
And what is your role with the superintendent?
I am the UPK, Universal Pre-Kindergarten Coordinator.
Universal Pre-Kindergarten. So that's UPK. I've heard of
UPK.
TK, and that's transitional kindergarten?
Correct.
Is there a difference, or
There
are
is
they-
a difference.
Okay.
So Universal Pre-Kindergarten is anything that happens before kindergarten. So that could be private preschool, that could be California State Preschool, that could be Head Start program. TK is also one of those pieces.
So is there an age limit or when you can start each of these different ones?
Yes, so this coming school year in 25-26, children will be able to enroll in TK if they are 4 by September 1st.
And they can do the other things earlier than that?
They can, yes. Some programs take them earlier, some take them at 4 years old, but this idea is that every child would have an opportunity to attend a high quality early learning program before kindergarten, and it's a parent's choice, so they can choose any of those options. But TK is a free option that happens at the school district.
Okay, that's what I was going to say, because I know at schools I see TK, but if you don't have an opportunity to go to a TK, that's where the UPK comes in.
Yes, right. Parents have a choice of what preschool program they would like their child to attend.
Okay, so let's talk a little bit about what you've got in front of us, because I know a lot of people are going, all right, well, what's going on here with the bears, right? So these are some manipulatives, and there's reasoning behind the color and the sizes.
Yes.
So this is what kids are going to see a lot in TK and UPK, because learning through play
Total the
is
foundation,
the key.
right? Absolutely. It's the foundation of preschool and TK learning. Children learn best through play, when they're active, when they're involved, and when they're engaged.
Well,
and
I think
so,
adults learn best through play also,
absolutely.
right? I mean, there's a lot of times when we're learning things and when we have our hands on things and we're able to play things.
Absolutely. Same
So
principle.
you know the Chief of Staff, Steve Sanders.
I do.
He comes down here and we play games every year.
Okay, well.
And we both learn.
Right.
Right? So it
Same
works
concept.
for kids at 4 and even 44, even though we might be a little older
Right.
than 44. But anyway. So I know that we have a couple of videos.
We do.
And we want to talk about counting and cardinality and the cardinal numbers.
Yes.
So let's take a look at the first video.
Okay.
3, 5, 6, 7.
What comes after 7?
7.
What comes next?
7. 8.
All right. So they're counting, obviously. And what comes after 7? 7.
Right.
What comes after 7? 7.
Right.
And then they get to 8. So kind of what was going on with the video?
So the parent was kind of working with the child on how to count. And what we want parents to know is that the rote numbers, 1, 2, 3, 4, 5, 6, that reciting those numbers is one part, but the other part is knowing how to assign one-to-one correspondence. So that's where the bears come in, that's where the objects come in, so that children understand that when you touch something, each one has a value, has a number associated with it, and that builds their counting skills. So she got a little confused there as she was counting with her fingers and stopped. So what you see here is that at home, you can do all of these activities with your child. You don't need to go buy flashcards, you don't need to buy workbooks. You can do everyday activities at home and build those counting skills by allowing them to touch and count things that are chores in the house or other things that they come across.
Yeah, I was going to say, because, I mean, there weren't flashcards and workbooks around all the time before,
No.
right? And obviously, people were able to understand mathematics and learning, and a lot of times it's because those weren't available.
Absolutely.
Right? They had to use their hands and touch things and count things and physically do things and count them as they were doing them.
Right, and every parent, every home has those materials. You can use silverware, you could use pens, you could use books, anything at all to practice counting.
Right, and I think the key there is when you were saying the parents just be involved.
Absolutely.
Just work with the students, like, all right, so instead of giving me 5 of these, all right, well, what do you mean 5? Right? And I know 5 comes after 4, but how many is that when I actually do it?
Right.
Right, so start counting them out.
Yes.
And as soon as the child can speak, I would assume you're going to want to have them start counting things.
Sure, and the cardinality is one piece. So the counting 1, 2, 3, 4, 5, 6, that's the cardinality, that's one piece. But the also having them touch and do those activities, that helps ingrain that in their brain, that this is 1, this is 2.
Every time they're doing something.
Right, that's how they're building those skills.
Okay, so I know that we saw a little bit of how they are doing that at the house and things like that, some examples of that. So in a regular classroom, let's take a look at that.
There's one more. Okay. Which finger? All right. Count them. Take them off and count them. Oh. Oh, I like how this idea of you putting it back in there. 2,
3, 4, 5,
7. Buddy, give me high fives on.
So success with that, actually using the objects, taking them out, counting them, putting them back in.
Right, and you could see she had a variety of objects there. It doesn't have to be bears. You can have any kind of collection or any kind of arrangement, and the children just practice counting.
Right, and then this also incorporates sizes, colors. So you're emphasizing more than just counting.
Absolutely. At this age, learning is integrated. So we're talking math here, different concepts. So cardinality, we're talking size and shape. They can sort them.
Right, different attributes.
Absolutely.
Right? So you can say, you know, like a child goes, all right, you know what, I'm going to take these, right? And then they'll let you, well, why did you put them like that? Right, and see what the child comes up with. And if they can go, well, they're all the same color. Great, that's one thing.
Right.
They're all different sizes. That's another thing, right? Something like that. So
Yes.
So they're getting more out of it than what they actually might
Absolutely.
comprehending at the time, but that's building that base and a foundation.
Absolutely. And by asking them, why did you sort it that way, and not telling them how to do it,
Right.
let them tell
Right.
you.
Hey, can
They're
you put some
building
together
those
for me?
critical thinking skills, reasoning skills.
All right.
Yep.
So anything else you want to tell us about TK, UPK? Because I know there's a lot going on, and there are a lot of students in TK now. It
There
seems like,
are.
as opposed to when we were in school, you just started in kindergarten.
Right. So next year is the year where they will be the youngest, and that's full implementation when they will be 4 by September 1st. So if you have a child who's going to turn 4 by September 1st, they're eligible to attend TK. So you can reach out to your local school district and get signed up.
Do you find many students are successful going in at 4? And are there times when you like, you know what, maybe we should have held off on some of these or moved the date back a little bit sometimes?
They're young, absolutely, but I think when you have a classroom that's play-based and they get that social experience and they're learning how to be with other children, I think they assimilate okay. Some children may not, and parents can decide, I'm going to keep them out for a year, and that's the beauty. It's voluntary. You don't have to put them in TK, so you can wait to kindergarten if they
So
feel
do you
like
find
it's not a
many
fit.
parents do that where they bring a child into TK because they want them, you know, to kind of get a head start on things, and then they find, for whatever reasons, it's kind of not working right now, and they...
I don't think often. I think the children acclimate really well. I think once they're engaged in the learning and they start to kind of get over that little separation anxiety, they really flourish and they have a great time in the classroom.
Right. I mean, if you're having fun, it's like, hey, you know what? You know, I'm not worried about where mom
That's
and dad
right.
are
You have
now.
fun
I'm
playing.
having fun, and we're doing this thing.
That's
and
right.
it. So,
Yep.
All right, Amy. We
Thank
certainly do
you.
appreciate
Thank
you
you for
taking some
having
time
me.
coming and talking to us a little bit about TK, UPK, and numbers and just how important they are,
Absolutely.
and having something physical to correlate as they're counting those right
Absolutely.
there. All right. And we'll be back with more right after this.
The Tragedy of the Commons says that self-interest in competition can cause people to ruin a shared resource. In this case, farmers who shared a pasture overgrazed the cows for a little more milk for themselves and ended up destroying the pasture for everyone. Is there anything that could have been done? If people ruin what they share, sometimes the best avenue is to have them not share. Each farmer's self-interest will ensure that they protect their own property. But not everyone is okay with making public land private property. And some things like the oceans and the sky can't be made private anyway. Luckily, people can cooperate to protect the commons, especially if they feel like it's a shared sacrifice. Freeloaders, though, can make everyone else feel like suckers. And sometimes it only takes a few cheaters to ruin the commons for everyone. In those cases, rules are required. Research supported by the National Science Foundation has shown that privatization, cooperation, and regulation can all work to protect commons, but only if proper enforcement exists. Resources common to multiple groups can be the hardest to protect, and that's a challenging task for everyone.
And once again, a big thanks to Amy talking about TK and UPK and the bears right there. And I remember when I taught a younger grade, we used to use frogs. And that was an introduction to math, and then also a little higher level math than TK, UPK, but then talking about science and frogs and dissection a little bit to get them interested in science, and always cool using frogs and things like that. But Haaris, how are you feeling today?
Good.
All right, good. So I know you guys are working on some division. You're a 4th grade student from Reagan, and I know you guys did great with that first problem. So I think Scott's going to go back to that 36 divided by 3 and work on another way of looking at that before we move on.
Now, you told me when we did this problem initially that you kind of had it in your head already, right? You already knew your basic times tables. 3 goes into 36 12 times. But what if the problem was set up like this? A lot of times we'll see division problems set up like that, where the first number goes inside a little house and the second number goes outside, how would you go about doing that problem? I'm going to give you a little bit of room here. If you saw the problem that was listed like that, we know the answer is 12, but show me how you'd actually do that one.
I could do, I know 3 could go into 3 one time, so I'll write a 1 right here.
I'm so glad you put it right over top of the 3. That's a great way to do it. Then next?
I can multiply that. 3 times 1 is 3. And then I subtract this.
Good.
And then 3 minus 3 equals 0.
That's right.
Bring down the 6. And then you have 6.
Yep. And then we'll repeat that process, right? You asked me, how many times does 3 go into 3? Now, how many times does 3 go into 6?
3 goes in 6 2 times.
That's it.
So I put 2 up here.
Oh, I like it. Good deal. And then you could multiply back together, right? 2 times 3 is 6, and you can subtract, and we love to have that nice 0 remainder at the end. Of course, if we didn't, we could put an R, no big deal. So let's look back at our really big problem here that we determined we could do it with circles and 1s and little pepperonis. But man, there'd be a lot of pepperonis, right? There'd be a lot of stuff to do there. We could do it, but it would take quite a while. So we'd like to have a formula or a way to do it just like you did there. So let's set this problem up here. 5 goes into 1,345, right? That's the problem we're looking at there. Can you come over? We don't even know what the answer is here. Let's see what you do with this one. I'm going to give you a different color. Start with green.
So 5 goes into 1 0 times, so I could put a 0 right here.
You could, that's right.
So I'll start from the 1s and go to the 3, then 4, then 5.
Okay.
So then 5 goes in 3 0 times, so I put 0 again.
Gotcha. But what about the 1? You said it went into 1 0 times. I totally agree with that. But we can't just ignore it, right? 1 doesn't just go away. It's still around. So what are we going to do with that 1?
You're going to put it inside remainder.
Ah, interesting. I like it. So we're thinking about that a little bit, and I like what you did there. I'm going to draw our line back there, just like we wanted it to be. But let's say we'll take your theory that you did over there, or your method, right? 0 times 5 is 0, right? And we subtract. 1 minus 0 is 1, and you bring down a 3. So see how the 1 didn't go away?
Yeah.
Really what's happened is the 1 stayed there, and we bring down the 3. And sometimes people will look at that and go, oh, it didn't go into 1, but it goes into 13. That's where the 13 comes from. So how many times does 5 go into 13?
2 times.
That's it. And where does the 2 go?
Above the 3.
Well done. That's exactly right. That's a really important process. Good. Keep on going.
5 goes in 4.
Hold on, remember, so we have the multiplication part, just like we did over there, right? So 2 times 5?
10.
Good job. And you're going to subtract. There you go. Now we're on a roll. And so we have 3 left over in that part. And what comes down next? I'm going to switch you back to red.
Like 5.
So you have 3 here. And what's going to come down next? We already used the 1. We already used the 3.
4.
Let's have the 4 come down. That's it. You got it. And we're going to make that little arrow. I like how you did that before, so you can see that the 4 comes down. Now, how many times does 5 go into 34?
6 times.
That's it. You're really right on with that part. You definitely have to know your multiplication chart or your multiplication facts in order to do division, right? It's kind of a wild deal. Okay, what's 6 times 5?
6 times 5 equals 30.
Good. You can put that right into the 34. And what do you do there? I subtract. That's right.
34 minus 30 equals 4.
Good. And we have one more thing to bring down, huh? We've used the 1. We've used the 3. We've used the 4. What's left?
The 5.
That's it. Bring it on down.
5 goes into 45 9 times.
That's it. Good job.
So the answer will be...
And 9 times 5. Let's see if we have a remainder.
9 times 5 equals 45.
Put it right underneath there. And what's the remainder?
0.
Nice. It's nice to have a remainder of 0. Now, if you wanted to be absolutely sure, let's say you're betting $100 that this is the right answer, and you want to make absolutely sure that that's the right answer. Do you know how to check your answers with a division problem?
No.
Oh, that's a good thing to know. I like it. It comes from this operation that you did right there. So if you did, it's going to be way up here, 269 times 5, what do you think that answer should be? Before you do it, what do you think the answer should be?
Like...
This number right here times this number right here. What should the answer be?
Somewhere in the thousands.
It is, that's right. This is the number we're looking for. If it happens to be 1,345, then we know we've done the problem correctly. If it doesn't happen to be 1,345, then we know that this answer probably is not right. So that's a way you can check your answer. Isn't that cool?
Yeah.
You want to give it a shot?
Sure.
All right, real quick, here we go.
So 9 times 5 equals 45.
Yep, that's right.
Put down the 5.
And we got a 4 way up here, huh?
Carry the 4, so
Yep.
5 times 6 equals 30. And then plus 4 equals 34.
Good for you.
You put down the 4, carry the
Yeah,
3.
and I'll carry the 3 for you. There you go. So far, so good.
5 times 2 equals 10, plus 3 equals 13.
That's it. And look at that. That's a wonderful check. At the end of division problem, you can multiply it out, and you can come up with an answer that hopefully is the same as what you started with.
Good. I'm glad you guys did that, and I'm awfully glad that you were able to use his multiplication skills because he's able to do the math facts just like that.
Yeah.
And that helps when you're doing
Helps a
division
ton.
in the first place, being able to recognize whole numbers that work like that. And you guys came up with a nice one. Too bad it wasn't 1346 divided by 5, but maybe we'll get into those a little bit later on.
Next time.
636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And just in case some of you are new to the program, and also adults, you're free to call all the time as well. There are a lot of times students don't have an opportunity to use the service that we have here at Do the Math because of after-school activities. Parents, you are more than welcome to phone in also and find out some different strategies to possibly help your students when they do have time to work with you on their math homework. We'll be back with more right after this.
Space Place. In a snap. Searching for other planets like ours. Earth is the only planet we know of that has living things on it. But could there be others? Do planets outside our solar system, called exoplanets, also have living things? We don't know, but NASA scientists are looking. They watch the starry skies for planets similar to Earth, ones that are about the same size, that are just the right distance from their star. We call this distance the habitable zone. It's where the temperature of the planet would be similar to Earth. A planet about this temperature could have liquid water on its surface. Water is necessary for life here on Earth, and it is probably necessary for life on other planets too. We don't know what living things on other planets would look like, and they might be so small they could only be seen with a microscope. So how do we find planets that could be homes for living things? We look at stars. We watch other stars closely to see planets pass in front of them. When a planet crosses in front of a star, it's called a transit. The planet blocks a small amount of light from the star. We can see a very small change in the star's brightness. This is how we can tell there could be a planet there. A NASA spacecraft called Kepler has found thousands of exoplanets this way. Future missions will be searching too. And who knows, maybe one of those exoplanets could be a home for living things. Find out more about other stars and exoplanets at NASA Space Place.
Exoplanets are cool. A lot of stuff about NASA is. In studio, we have Haaris, a 4th grade student from Reagan, working on multiplication and division and remainders. And now, young man, we're going to move you on to the next step, fractions into decimals. Scott, let's take it away.
So let's say that we have a fraction like 3/10, something like that, right? What do you know about 3/10? You said you've done some fractions before. You've seen fractions. If I put 3 over 10, tell us anything at all that you know about that.
That it means that there's 3/10.
Okay, and tell me a little bit more about that. What does that mean? Like if you had a pizza, right? I know you like pictures, and you were drawing pizzas earlier. So let's see here. We have that one, and we got that one, and we got that one, and we got that one. They're not exactly equal, but 1, 2, 3, 4, 5, 6, 7, 8. Oh, we draw one more. There we go. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces of pizza, not evenly distributed because I'm drawing, but still, you get the idea, right? Mm-hmm. So if you had a picture of what this looked like, what would it look like on my pizza there?
It would look like there's only gonna be 3/10 of the pizza left.
Gotcha. You want to shade in 3/10 for me real quick?
Sure.
So there's one of them, right? There's one piece. And there's another one. Good. And there's another one. So there's a visual representation of 3/10. That's exactly it. Do you know what the top number is called?
The numerator.
That's it. What about the bottom number?
The bottom number is the denominator.
All right, so we have some vocabulary that goes with that as well. Now, have you ever seen a fraction changed into a decimal?
No.
Okay. So let's say we have this number 3.45, right? Or maybe we'll have 63.45. What number or what is the place value of the 6?
60.
It is 60, that's right. And what place value, how do we name that place value? In other words, what's that?
It would be the tens.
The tens, that's it. I like it a lot. And what about the 3?
That would be the ones.
The ones, that's it. Now the question is, do you know what the number is after the decimal?
Tenths.
That's it. You're exactly right. So this is tenths with the THS in the end. You got to make sure you put your hand over your mouth sometimes so you don't spit on the person next to you. But that THS at the end makes this different than the other one, right? Just out of curiosity, do you happen to know what the 5 is?
The hundredth.
The hundredths, that's right. So you really do know a little bit about some decimals. And that's a good thing because those ones after the decimal always have that THS at the end. So we have a picture of 3/10. Can you show me what it would look like if you were going to write 3/10 in a decimal? Where would the 3 go?
The 3 would go into the ones.
Well, it says, remember, we said that this was 3/10. Where is the tenths place in the stuff that you've done already, right? The places that I've given you. I've given you 3 spaces. I've given you 1 before the decimal and 2 after the decimal. Where is the tenths place, according to what you told me here?
The tenths is right here.
That's it. So that's where the 3 goes, right? Go ahead and put the 3 there. That's it. And do we have any ones in this fraction here? There's nothing there, right? No, we don't have that. Do we have any hundredths in this fraction here?
No.
We don't have anything there either. So if you were going to write this in a decimal, that's one way you could write it, with 0 in the ones place, 3 in the tenths place, and 0 in the hundredths place. It's one way to write it. There's also another way that you can get that same exact thing using the division that you already know. Are you ready? Here we go. Here's what we're going to do. What this fraction says is 3 divided by 10, right? Okay, so that means 3 divided by 10.
Okay.
That's a strange problem, isn't it? Does 10 go into 3?
No.
It doesn't. But we're talking about decimals. So we're going to put a decimal right there, and we're going to put a decimal right up here, and we're going to go ahead and add a 0. Because we know that it doesn't matter what happens after there. Same thing here. It doesn't matter what happens after the decimal as long as it's a 0. So come on over here and see if you can figure out the rest of this problem. How many times does 10 go into 3? You told me what?
0.
0. Go ahead and put a 0 up there. How many times does 10 go into 30, though?
3 times.
3, that's it. Go ahead and put a 3 up there. Is that similar to what we had written over there?
Yeah.
Look at that. So that's one way you can do this. 3 times 10 is 30. And you can see that we have a remainder of 0. One way you can change this fraction into a decimal is by using division like you did earlier. Another way you can change this fraction into a decimal is by putting this number in the tenths place if it happens to be a fraction with a 10 on the bottom. A couple different ways of doing it there. I like it.
You guys good for one more?
Oh, yeah.
Clear the board.
All right, we can do that. Let's add one.
There you go. How
Okay.
about 7/10?
Okay.
And Haaris, go ahead and explain to Scott how you can write 7/10 in decimal form now.
So you would put a dot right here, 0.
Okay. Because that's 0 in the ones place, and we don't have any ones, right?
And then in the tenths, you would put the 7.
Yep.
And then since there are no hundredths,
Yep.
you could put a 0 there.
Now the next place, you're exactly right. I love what you've done here. The next place after the hundredths is called the thousandths place. You might have heard that before. Are there any thousands?
No.
Go and put a 0. The next place after that is called the 10,000s. Are there any 10,000s? No. What about 100,000s? Or millions? Or 10 millions? Or 100 millions? Anything over there? We could put a bunch of zeros. We could draw zeros for the rest of the day, and none of this would matter that much. The significant digit that we need to have is the 7 in the tenths place. That's pretty important. Good
So I'm
job.
glad you brought up significant digit because that leads us into scientific notation now.
I like
where
it.
we're going to go negative exponents. I'm only kidding with you right there. So,
Something to look forward to.
so on the left-hand side of the board, let's try 1 3/10. And try that one, and then we'll probably end it there.
I like it. So this is just a little bit different, but we got to change this into a decimal. Okay? Tell me anything at all you know about what we're going to do with this one.
So for the ones, we could put, so for the left, on the left side of the dot, we could put a 1 since we have a 1.
It's in the ones place. That's wonderful. Go ahead and do that. Give it a try. So on the decimal, we have a 1 now in the ones place, like a whole number. All right, what's left?
The 3/10, so you could put 3.
Yep.
And then the 0.
You could put a 0 there, and you can put 4 more zeros. Do you have to have this 0 here?
No.
So this 1.30 is the same as 1.3, right, with no 0.
Yeah.
It's also the same as 1.3000000000. They're all the same because those zeros are not significant. The important numbers we have to have are the 1 and the 3. I think you learned a little something about some decimals today. Good job.
Yeah, he is learning quite a bit. And I know that you had some good vocabulary with numerator and denominator with the fractions. Now, a lot of times when you get introduced with the decimals and things like that, students go the dot or the point or the decimal. So talk a little bit about how to read that instead of saying 1.3, how to read that mathematically.
I like it. So there's a word that we do like to have instead of saying a dot or a point, right? Some people will say 1.3, but in mathematical terms, we want to actually use the word. You know what the word is?
No.
Actually, it's a pretty simple word, and, right? So in this case, we have 1. In the middle here, we have the word and you can see that 1 and, how would you say this one?
1 and 3.
1 and 3 what?
Tenths.
Tenths, that's it. So this is how you'd say the whole number all together, right? 1 and 3/10. And so that decimal represents the word and that's how we say it kind of in everyday language. You can translate from numbers into language.
There you go, nicely done. So come on over here, boys. You did some great work on that decimal right there. So, Haaris, come on over here. So, you are now an ambassador for Do the Math. You know what that means?
No.
You simply have to tell other students and anybody you run across about Do the Math. You think you could do that?
Yeah.
That's a pretty simple job, isn't it, right? All you have to do is say, hey, you know what, there's this thing called Do the Math, and they'll go, what are you talking about? And you can tell them all about it, right? Because you were a guest. You're going to be world famous after tonight. Did you know that? I saw a smile come on your face right there when I was talking about that. Do you have any idea what this is?
A Rubik's Cube?
Are you a master of the Rubik's Cube?
No.
Yeah, neither am I. Scott?
Nope, not me.
No, neither am I.
Too many
either.
colors.
Well, you know what? It's something that you can try out and maybe learn a little bit about it right there. But this is an exclusive Do the Math Rubik's Cube. You're one of only a select group of kids that has this thing. Pretty good? All right, you know what? Halloween is coming up. We have Safe Halloween coming up, and that is taking place at the Kern County Museum. That is coming up October 30th, Wednesday and Thursday, Halloween, of course. So the 30th and the 31st, beginning, I think it is 5 to 9 each of the nights. So that is happening at the Kern County Museum, a little bit on North Chester right there, past the circle. So a lot of times, kids want to go out and they want to have fun, and a lot of times parents are wondering, like, where can we bring them for a safe place? So you can bring them to Safe Halloween. That is coming up October 30th and 31st. That is 5 to 9 p.m. And we can see a lot of the people that sponsor this program and some of the past participants. That's pretty clever right there with the head like that. Is that your idea, Scott? You do that with one of the kids? Is that you in the background right there, I see?
I like that.
Yeah, anyway, that's coming up. Safe Halloween at the Kern County Museum, October 30th and 31st. That is from 5 to 9 p.m. Haaris, we want to thank you for coming in today. Did you learn a little bit of something today?
I learned a lot about decimals.
Good. Did you have some fun today?
Yeah.
That's the most important thing right there. Remember, you are our newest ambassador. You all good with that? All right, good. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.